Lesson 13 is once again on the unit circle. I've mentioned a couple times in class that there's more than one way to measure an angle. So I was telling you that when you used your calculator, remember I said make sure you get the same answer as I do because there are different modes. There are different ways to enter angles or measure angles. So you have to make sure that your calculator is set to the one that you want in the current problem. And we've been working with degrees. That's all you've ever worked with. In geometry, you worked with degrees. This year, we've been working with degrees. But another one that's probably more common, actually, the higher you get in math, the more often this one is used over degrees. And that is called radians. So degrees, you'll know it's degrees if there's that little degree symbol up in the corner. If it doesn't have that, then the measure is probably in radians. So I'm going to briefly explain to you what 1 radian actually means, what that measurement is. But then mostly I'm going to focus on, this is the same as lesson 15, where you're using the unit circle to find tangent of an angle or sine of an angle, except that now that angle will be in radians. And it's hard to get your brain away from the 360 degrees that you're used to into this kind of different measurement. So if you have a circle, any size circle, it does not matter, and you know the radius of it. If I took that length, that radius, and think that I could make it like something bendable, like string or pipe cleaner or something, sometimes in class we've actually physically done this. If I could take that length of that radian and wrap it along the circumference of the circle, so this length is the same as this, that angle that's created right there is called a radian. It's called a radian. Okay, so the unit circle, this is where pi comes from. 1 full rotation around the circle is 2 pi radians. So it means halfway around the circle is 1 pi, and then we kind of just split it up into smaller pieces. So if you think that half a circle is 1 pi, each of these fractions just represent how much of the circle we cut it into. So like pi over 6 is 1/6 pi. It's a sixth of this semicircle. 1/4 pi, pi over 4 means 1/4 of a pi. So it means I cut this semicircle into 4 pieces. There's 1, 2, 3, 4. So it's literally just a fraction, and then the pi. So this is 1/3 of a pi. I cut this semicircle into 3 pieces. There's 1, there's 2/3, and then 1 would be 3/3. So what I want you to notice, because these are a little bit tough, is that all of these inside angles, so this one and this one, all the ones that are closest to the x-axis, those all are something over 6. And the ones that are over a 6, anytime you see it over a 6, that is going to be a 30-degree reference angle. So all of these ones over 6, 30 degrees, 150, 210, 330, those all make 30-degree reference angles. So when you're going back to your 30, 60, 90, or 45, 45, you'll know it's a 30. If it ends in or if the bottom is a 4, that's a 45 reference angle. So all the 4s are in the middle. Those are all 45-degree reference angles. So this unit circle is symmetric. You can like flip it, like this one matches this one. The middle matches the middle. This like top one matches this bottom one. That's why the other day when I was telling you about using on the unit circle the negatives, that I find the positive and then like flip it over, it's because the whole thing is symmetric. So half away around the circle is 1 pi. A full rotation is 2 pi. You can go around more than that. So every time you go around the circle, that's 2 pi. So it'd be like 2 pi, 4 pi. So if I said, where's 11 pi? You would go around. There's 2, 4, 6, 8, and then 11 would be, 10, and then 1 more for 11. So 11 would get you to over here. So we're going to use this unit circle that now has radians, these measures on it. Everything else stays exactly the same. And we're going to evaluate trig functions. Find the exact value of trig functions. So tangent of 5 pi over 3. You look on that circle up there and you find 5 pi over 3. So again, thinking about fractions, right? 5/3, that's not quite 2. 6/3 would be 2. So 2 pi would be all the way over here. So you kind of want to know where to look for it. 5/3 is not quite 2. So, oh, here it is, not quite to 2 yet. So tangent is y over x. So the y coordinate is negative root 3 over 2 divided by the x coordinate is 1/2. We have to multiply we have to divide fractions, so we have to multiply by the reciprocal. So negative root 3 over 2 times 2 over 1. When you're multiplying, you multiply straight across, so we end up with 2 over 2, which is just 1, so we get negative root 3. For B, cosine of 4/3 pi. So 4/3 is a little over 1, right? So here's 1. 4/3 is going to be past that. There it is. Cosine is the x coordinate. At 4/3 pi, the x coordinate is negative 1/2. So all of this part is exactly the same as what you've been doing. Using the unit circle, the y over the x, the simplifying, all of it's exactly the same. The only thing that is different is that angle measure, and you just have to kind of get used to where they are and practice with them, to be honest. Okay, cotangent of 7 pi over 6. So again, 7 pi over 6. 7/6 is a little bit more than 1. So it's a little past 1 pi. Here it is down here. Cotangent is x over y. So the x coordinate is negative root 3 over 2 divided by the y coordinate is negative 1/2. You'll get to the point, can you look up here and see this is the exact same problem? Like we just did this one exactly. The only difference is that this one was negative. This one is going to be negative divided by negative is positive. So I could go through and do this again, or I could just use the work that I already did. Sine of negative 5 pi over 6. So we're going to do the trick we did the other day. We're going to go to positive 5 pi over 6. And then I'm going to flip it over. I'm going to go symmetric on the other side would be down here. So it's at this 7/6. And sine is the y coordinate. The y coordinate at that point is negative 1/2. Okay, so the last two of these are if you go around more than 2 times. So 11/2 is not on the unit circle. That is nowhere on there. So I'm going to change 11/2. 2 goes into 11 5 times, and there's 1 left over. So 11/2 is 5.5. So where is 5.5 on here? Well, we go around. There's 2. Every rotation around the circle is 2 pi. So 2, we go around a second time, that's 4. I want 5. So there's 1 more is 5.5. Halfway would be down here. So I'm at this point. What was it? Cosine? Cosine is the x coordinate. X coordinate is 0. So this one is 0. And then one more of these, cosecant. 4 goes into 21 5 times. So negative 5. There's 1/4 left over. Okay, so negative 5 and 1/4. So around our circle, we're going in a negative direction. So we're going down. Once around the circle, there's 2 pi. Another time around a circle, there's another 2 pi, so that's 4. Over to here, there's 5, and then I want to go 1/4. So here's the one that's 1/4. So I'm right here. I'm trying to find cosecant, which is 1 divided by the y. The y is root 2 over 2. So 1 divided by radical 2 over 2. So this one we need to simplify. 1, instead of dividing, we're going to multiply by the reciprocal. We can't leave it with a radical in the bottom, so we need to rationalize, which is when we multiply the top and the bottom by root 2. So I get 1 times 2 is 2 times root 2. And then in the denominator, 2 times 2 is 4. Square root of 4 is 2. But then you can simplify again because 2 divided by 2 is 1. So we get 1 root 2. And then the one other thing is converting back and forth. I want to show you how to convert. I want to show you how to convert. So there's a little graphic up there for you, going back and forth between degrees and radians. So follow the arrows. If you're in degrees, you want to go to radians, then you multiply by pi over 180, and then we reduce it. If you're in radians and you want to go to, follow the arrow, you want to go to degrees, then you multiply by 180 over pi. So this first one, negative 45, is in degrees. We want to convert to radians. So to go from degrees into radians, we multiply by pi over 180. So pi over 180. We're not going to multiply pi's in. We're going to leave it alone. Okay, so we get negative 45 pi over 180. And then you always want to see, can you reduce that fraction? 45 goes into 180 4 times. So it is negative pi over 4. 45 over 180 reduces to 1/4. So you get negative 1 pi over 4. Let's do, okay, we can do this one. So this one's in radians. You know that because there's no degree sign. Anytime there's a degree sign, it's in degrees. No degree sign means radians. Even if you just had like a 6 right here, that would be in radians if there's not a degree sign. So this one's in radians. We want to convert to degrees. So from radians to degrees, we multiply by 180 over pi. Likely the ones that you get will all have a pi in them. So here, pi over pi is 0. Those cancel. You can multiply 5 times 180 and divide by 6. I'm trying to do it mentally. So 180 divided by 6 is 30. And then 30 times 5 is 150. So I have a couple more of those if you want to try to pause me and then see how you do. That'd be good. 80 is in degrees. We want to convert to radians. So we multiply by pi over 180. And then we have to reduce. We can divide them both by 10. And then I can divide them both by 2 to reduce. And the last one, 2 pi, there's no degree sign, so it's in radians. I want to convert 2 degrees, so I multiply by 180 over pi. Pi's cancel because pi divided by pi is 1. 2 times 180 is 360, divided by 9 is 40 degrees.